In this video, we're going to talk about 9.1 Objective 3, where we solve applications involving adding vectors. Let's go ahead and get started. Two forces that act on an airplane wing are called lift, which are pounds of force in the upward direction, and drag, pounds of force opposite the direction of travel. So weight and thrust are the other two of the four forces in aeronautics. I find the result of these forces, the lift force and the drag force, acting on the airplane wing in the figure on the right. So let's go ahead and do that to find the sum of vectors. We would like to draw them in such a way where they are head to tail, like so, to make a right triangle. And this side is 300, and this side is 820. And we want the resultant R to be like that. And we're going to want to find this angle, and we're going to want to find this magnitude. Let's go ahead and find the magnitude first, because it's just the Pythagorean theorem. So the square root of 300 squared plus 820 squared. And they tell us to round to the nearest whole number here. That's going to be 873. And then to find the angle, we're going to use the tangent function to say tangent of the angle is 820 over 300. So theta is going to be arctangent of 820 over 300. Make sure you're in degree mode. And they told us to round to the nearest whole number, so that's going to be 70 degrees. Sorry. A ski toe is moving skiers vertically upward 27 meters per minute. So that looks like already that's this one. Horizontally at 47 meters per minute. But again, I want these head to tail if I can, like so. So that this side is 27 and this side is 47. That gives me a resultant that goes like this. The square root of 47 squared plus 27 squared, rounding to the nearest whole number, is 54. And then arctangent of 27 divided by 47 is going to be approximately 30 degrees from the horizontal. Three ropes held a helium balloon in place, but two of the ropes break. The remaining rope holds the balloon with a tension of 480 newtons at an angle of 80 degrees with the ground due to a wind. The weight, a vertical force in the downward direction of the balloon and its contents, is 350 newtons, and the upward buoyant force is 825 newtons. So those are in the same plane. That's why you see this vector that looks, this part that has arrows on both ends is dark. It's because there's two lines. There's a big arrow B going up here. This arrow pointing up, that's B. And then there's another arrow here that's pointing down. That's W. Just so you see that those are next to each other, and that's why it's dark there, is that B is much bigger going up here, and W is going down. Now I would have put W going down from the balloon, and that would have been from here, but whatever. we'll deal with it as it is. This is the correct diagram here that shows the wind is coming horizontally. The tension is at 80 degrees with the ground. It's not quite vertical, but it's almost there, right? And the tension is in such a way where it balances out these other forces. And they want you to see that the wind zeroes out this part of the buoyancy, and you're left with this right triangle here that forms a closed loop. When we're done, when we've put all these forces together on our force diagram, and they tell you that if your force diagram makes a closed loop like this, that the resultant is 0, because what's going to happen is when I take the wind and the buoyancy, I get the resultant is equal and opposite to the tension. Then I add it to the tension and it zeroes out. So that's all they want you to see there, is because the unbalanced portion of the buoyancy plus the wind balances out perfectly with the tension there, since it's a closed loop. All right, well, unloading a crate weighing 630 newtons, the chain from a crane supports it with a force of 680 newtons at an angle of 22 degrees from the vertical. Watch out, that means that 90 minus 22 is going to be 68 degrees from the horizontal. So that looks like this one to me, 630 newtons of force this way and 680 that way. Let's go ahead and look at those vectors head to tail. So 680 here and 630 here. And I want to know how much is in this horizontal direction here that's unbalanced. So let's use the Pythagorean theorem for that. That we want second square root of 680 squared minus 630 squared. But there's an unbalanced force of 256 newtons in this direction. So I'm going to need a rope to pull 256 newtons in the horizontal direction that way to balance it out. And that's it. So everything here was Pythagorean theorem. We can use sines and cosines to break things up into components as well as another method. And if you take a physics class, you will learn more about that. But next time we'll come back and talk about 9.2 objective 1. So I'll see you for the next video.